Hello and welcome. Today we're going to go through a number of creational design patterns in detail. Creational design pattern provides object creation mechanisms that increase flexibility and reuse of existing code. Example patterns are Singleton, Prototype, Builder, Abstract Factory, and Factory Method. Factory Method pattern provides an interface for creating objects in a superclass, but allows subclasses to alter the type of objects that will be created. The participant classes in this pattern are Product Interface, where it defines the interface for objects that the factory method creates. We also have a concrete product that implements the product interface. The factory declares the factory method, which returns a product object, while the concrete factory overrides the generating method for creating concrete product objects. So when do we apply this pattern? We use it when you don't know beforehand the exact types and dependencies of the objects your code should work with. Also, when you want to provide users of your library or framework with a way to extend its internal components. Lastly, when you want to save system resources by reusing existing objects instead of rebuilding them each time. What are the pros and cons? First, it avoids tight coupling between the creator and the concrete products. You can move the product creation code into one place in the program, making the code easier to support. You can introduce new types of products into the program without breaking existing client code. The only con would be the code may become more complicated since you need to introduce a lot of new subclasses to implement the pattern. Abstract factory pattern produce families of related objects without specifying their concrete classes. We have abstract products that declare interfaces for a set of distinct but related products which make up a product family. Concrete products are various implementations of abstract products grouped by variants. Each abstract product must be implemented in all given variants. The abstract factory interface on the middle part declares a set of methods for creating each of the abstract products. Concrete factories implement creation methods of the abstract factory. Each concrete factory corresponds to a specific variant of products and creates only those product variants. Although concrete factories instantiate concrete products, signatures of their creation methods must return corresponding abstract products. This way, the client code that uses factory doesn't get coupled to the specific variant of the product it gets from the factory. The client can work with any concrete factory product variant as long as it communicates with their objects via abstract interface. We should use the abstract factory design pattern when the system needs to be independent from the way the products it works with are created. The system is or should be configured to work with multiple families of products. A family of products is designed to work only all together. And lastly, the creation of a library of products is needed, for which is relevant only the interface, not the implementation too. Pros and cons. First, you can be sure that the products you're getting from a factory are compatible with each other. You can move the product creation code into one place in the program, making the code easier to support. Also, you can introduce new types of products into the program without breaking the existing client code. And we avoid tight coupling between the creator and the concrete products. Con would be the code may become more complicated than it should be, since a lot of new interfaces and classes are introduced along with the pattern. The more complex an application is, the complexity of classes and objects used increases. Complex objects are made of parts produced by other objects that need special care when being built. An application might need a mechanism for building complex objects that is independent from the ones that make up the object. If this is the problem you are being confronted with, you might want to try using the builder or the adaptive builder design pattern. The pattern allows you to produce different types and representations of an object using the same construction code. The participant classes in this pattern are: the builder class specifies an abstract interface for creating parts of a product object. The concrete builder constructs and puts together parts of the product by implementing the builder interface. It defines and keeps track of the representation it creates and provides an interface for saving the product. The director class constructs the complex object using the builder interface, and the product represents the complex object that is being built. Say you have a constructor with 10 optional parameters. Calling such a beast is very inconvenient. Therefore, you overload the constructor and create several shorter versions with fewer parameters. These constructors still refer to the main one, passing some default values into any omitted parameters. The builder pattern lets you build objects step by step using only those steps that you really need. After implementing the pattern, you don't have to cram dozens of parameters into your constructors anymore. The builder pattern can be applied when construction of various representations of the product involves similar steps that differ only on the details. The base builder interface defines all possible construction steps, and concrete builders implement these steps to construct particular representations of the product. Meanwhile, the director class guides the order of construction. The builder pattern lets you construct products step by step. You could defer execution of some steps without breaking the final product. You can even call steps recursively, which comes in handy when you need to build an object tree. A builder doesn't expose the unfinished product while running construction steps. This prevents the client code from fetching an incomplete result. Say you have an object and you want to create an exact copy of it. How would you do it? First, you have to create a new object of the same class. Then you have to go through all the fields of the original object and copy their values over to the new object. Okay, cool, but there's a catch. Not all objects can be copied that way because some of the object's fields may be private and not visible from the outside of the object itself. There's one more problem with the direct approach. Since you have to know the object's class to create a duplicate, your code becomes dependent on that class. If the extra dependency doesn't scare you, there's another catch. Sometimes you only know the interface that the object follows, but not its concrete class. When, for example, a parameter in a method accepts any objects that follow some interface. The classes participating to the prototype pattern are client, which creates a new object by asking a prototype to clone itself. Prototype declares an interface for cloning itself, and concrete prototype implements the operation for cloning itself. Use prototype pattern when your code shouldn't depend on the concrete classes of objects that you need to copy. This happens a lot when your code works with objects passed to you from third-party code via some interface. The concrete classes of these objects are unknown, and you couldn't depend on them even if you wanted to. The prototype pattern provides the client code with a general interface for working with all objects that support cloning. This interface makes the client code independent from the concrete classes of the objects that it clones. Use the pattern when you want to reduce the number of subclasses that only differ in the way they initialize their respective objects. Somebody could have created these subclasses to be able to create objects with a specific configuration. The singleton pattern is one of the simplest design patterns. It involves only one class, which is responsible to make sure there is no more than one instance. It does it by instantiating itself, and in the same time, it provides a global point of access to that instance. By doing it, the singleton class ensures the same instance can be used from everywhere, preventing direct invocation of the singleton constructor. The implementation involves a static member in the singleton class, which keeps the reference to the instance, a private constructor, and a static public method that returns the static member reference. The singleton pattern is used in the design of logger classes. These classes are usually implemented as singletons and provide a global logging access point in all the application components without being necessary to create an object each time a logging operations is performed. The singleton pattern is also used to design the classes, which provides the configuration settings for an application. By implementing configuration classes as singleton, not only that we provide a global access point, but we also keep the instance we use as a cache object. When the class is instantiated, the singleton will keep the values in its internal structure. If the values are read from the database or from a file, this avoids the reloading of values each time the configuration parameters are used. Now that you know all the creational patterns, comment down below which one is your favorite or the ones that you use the most. Thanks for watching. Until the next video, happy coding!